Okay, so today we are going to talk about multiplying polynomials.
Ooh, more polynomials.
More polynomials. What is a polynomial?
Multiple, more than one number or something like that.
Right? Do you remember the word of what those are?
Yeah.
Terms?
Yeah.
Okay, so we have multiple terms.
Binomial, trinomial.
Right, and then we can specifically name them as a monomial if it's one term, a binomial if it's two terms, a trinomial if it's three terms.
And a quadrinomial if it's four.
We're going to do the exact same thing we did on Wednesday, except now we're going to do it with multiplication. Right, so we learned our first week about how we add a monomial plus a monomial, how we multiply a monomial times a monomial. Right, and now we're taking that to what do we do when we have multiple things being added, or now today when we have multiple things being multiplied. And when we are talking about multiplying polynomials, it is all based on one key thing. If you know how to distribute, the rest is taken care of for you. It is just a whole lot of distributing. Okay, so we can start distributing, we have been distributing from a very basic level, where we can have something like 3 times 2x squared plus 4x minus 8. And the idea is that those parentheses are representing multiplication. And since there are multiple terms inside of here, we need to multiply that outside number to each individual term on the inside. Okay, so we're taking this 3 and we're distributing or passing it out to each piece. So we'll pass it out here.
Yeah, this is the thing we were talking about.
So 3 times 2x squared is what? 6x squared, because the big numbers get multiplied together. Right? What are those big numbers called?
Coefficient.
Coefficients. Then we'll go to the next one. 3 times 4x is what? 12x.
Negative 24.
Hang on. Okay, so you're saying negative 24, Bryson. Where are you getting the negative from? But isn't this subtraction?
It's also a negative.
Right? It's both of them. It all determines on how we want to read it.
Can we change the sign?
Okay, so this is a negative 8 when we just look here. And negative 8 times 3 is negative 24. But when we read it in the entire context, then it's subtraction, which is fine. Okay. These can look slightly different. Depending on what monomial we have, this monomial over here isn't always in parentheses. But I'm just showing you some different looks. Because they're all telling us the same thing. It's a bunch of distributing. So this sort of has it flip-flopped. But it's still the same idea. We still want to take this and pass it out. Okay, so what is negative 2y times 5y to the third?
Negative 10y.
10y to the
Fourth.
4.
fourth. Where is that 4 coming from?
There's a 1 there.
Because there's a 1 here, and we add the exponents when we multiply. And then we'll pass it out here. So a negative 2y and an 8y squared give us what?
Negative 16y to
Negative 16y to the Because, right, we're adding 2 plus 1 is 3. Negative 7y times negative 2y gives us what?
14y.
Squared.
Yeah.
Right? Positive 14y squared. Because they both have an exponent of 1, and we add the exponents. Okay? Questions there? Now, as the polynomial gets larger, so if we're no longer distributing a monomial, we'll just have to do multiple sets of distributing. So if it's a binomial, a trinomial, they get longer, they don't get any more difficult. So maybe we have something like x plus 7 times x plus 2. Would we agree that we have some things over here that we probably have the same concept that we could distribute over here? We just need to figure out how to distribute them. Okay, so to distribute them, we're actually going to distribute the same number of times as terms that there are. So how many terms are over here?
2.
So we're going to have to go through that passing out process twice. Once for the first term. So I'm going to ignore the fact that there's a 7 at all. I'm just ignoring it. And I'm going to start distributing. So x times x is what?
X
2.
2.
X squared, right? X plus x is 2x. X times x is x squared.
Yeah.
Okay, then we're still going to be ignoring the 7.
Oh, yeah, I know what we're doing now.
And we'll distribute here. X times 2 is
2x.
2x.
And then now we do the 7. 7 times x.
Right? And then we're just going to redo the process all over again. But now we're going to distribute the other term.
Plus 7x.
Now, make sure you don't cover up that sign, right? Because this is telling me if that 7's positive or negative. So if I distribute here, 7 times x is 7x. Now, you have two choices. Option 1 is that you can write this 7x right here and keep working horizontally. That's how I was always taught for forever. It works, it's fine. Okay, but a lot of my students prefer that stacked look with addition like we had before. And so it will help if you say to yourself, is there any like term to 7x?
Yeah.
2x. And so let's write that positive 7x underneath it. And my student's like, what? That's really weird. Just give me a minute. Just sit tight here for a second and I'll show you.
And then she gonna add x together.
Okay, then we'll distribute to the next piece. What is 7 times 2?
14.
14. Okay, now that we have these pieces, we need to make sure we get like terms combined. And combining like terms is really just adding polynomials.
Yeah.
So we're just gonna add the polynomials. And if we wrote them stacked, they'll all just be matched up for us. So there's nothing to go with the x squared, so that comes straight down. 2x plus 7x gives us 9x. And there's nothing to go with the 14, so that comes straight down. And that's our answer. Do you have a question, Elijah?
Yeah. So like when we first get the first answer, anything that don't match up, it just kind of like goes off.
Just goes off to the side.
Yeah.
Yep.
Okay.
Yes, Bryson.
Wait, so trinomial is 2? Or
3.
3? Would that be the 3? Like you'd have 3 of the times?
No, that'd be like
This is a binomial times a binomial. And we get an answer that is a trinomial.
because you don't multiply.
this has two terms, so this is a binomial.
You can do a trinomial times a trinomial, right?
You could do the exact same process with a trinomial times a trinomial.
For those are-
They just start getting longer and longer and longer as you go.
That's annoying.
It is annoying, it's tedious, but it's not harder math.
What comes after trinomial?
Yeah, sure.
Wait, really?
Good question. I don't know. Look it up and tell me.
Alright.
Not right now.
Oh, I was gonna say, can I take class time to look this up?
No.
We lost our privilege.
Okay, so this is one of those things that, for real, if you know the process, you could do basically any multiplying with polynomials. However, I feel like I would be doing you a small disservice if I didn't explain one thing. PEMDAS. What is PEMDAS?
Please excuse.
Please excuse my dear Sally, but what is it for?
Oh,
Parentheses.
Okay, yeah, but why? Why do we use PEMDAS?
It's like the basic.
So we're like in order of operation.
It's our order of operations. Okay? PEMDAS, those of you who've had me for first trimester, is kind of a big flat lie, and why it stuck so well, I don't know. It doesn't even include the right operations all the time, so whatever.
Wait, what?
Like, radicals aren't in there.
You just-
Multiplication does not come before division, they come at the same time.
Well,
But
that's what they say. They say you can add and subtract in the order that comes in the equation.
I know, but PEMDAS doesn't say that, it just says PEMDAS.
Miss McKinney, you
Right?
changed her whole way of math.
So, there's another one of those things like PEMDAS that's called FOIL.
Oh,
yeah.
I've heard
Okay.
of
See,
that.
now
Foil?
am I gonna get to college and they're gonna say,
No.
oh, that's not true?
Yeah, for real.
They're not, because I took all the college math classes.
And they said that FOIL was in there?
No, FOIL is like PEMDAS.
Well, like before
No, they're-
PEMDAS was
but
PEMDAS,
it's
right?
FOIL.
It just, it's, no. FOIL applies to this. People call this foiling. Right? You didn't come up with order of operations, but you knew what PEMDAS was.
Foiling.
People don't know what multiplying polynomials is, but they know what foiling is, because foiling stands for FOIL, F-O-I-L, is an acronym. It stands for first, outside, inside, last. And it was like a catchy term to remind you how to multiply all four of them.
That doesn't make sense.
Except it only works for a binomial times a binomial and doesn't work for anything else. And so everybody was like, wait, why is this sticking so well? And when I was taught, man, you foiled. And if that instead of being called multiplication, this was foiling. Like foiling could even be a verb.
Foiling.
Okay, so if you hear that word or you see it presented somewhere, that's where it's coming from. No one here at the high school teaches it that way anymore, but it is something that has just sort of stuck so well, it kind of just isn't going away and it just needs to go away.
At the what's it called, the homeschool I did last year, they call it foiling, and I was
What's
so
that
lost.
from?
Yeah.
SpongeBob.
Okay, so if we look at this one up here,
Ooh,
3w plus 5 squared. What do you think, Elijah? You got a thought here.
you gotta distribute that 2 in there.
That would be tempting.
Oh wait, you don't.
Because that is normally what we've done, right?
Wait, so you're telling me that that's 5 squared and that's not the 2 on the outside?
You don't want to give that 2 to each piece inside, no. And the reason why is because what does an exponent of 2 tell us to do?
Uh-huh.
Multiply the base by itself, right? What is the base here?
5.
3w plus 5, so we need to multiply it by itself.
Oh, this.
Oh, doesn't this look like what we just looked
So
at?
9w squared plus 25.
No, because that's not how we multiply these. We ignore this,
We have to distribute.
and we distribute
Why?
We just
Why
did it.
though?
9w squared.
My brain is processing stuff at a higher level. I'm just.
On a higher level.
Really?
Then we go here. What does this give us?
Yeah.
15w.
Yeah.
I was right about the 9 squared though.
Yeah. Right, and then we switch.
He said my brain.
Okay, so now we have 15w again. So I'm gonna write it underneath.
Plus 25.
Plus 25.
Oh, my head hurts.
I feel like you could do
How
this
does your head hurt?
whole
We've
thing
not done nothing.
No.
Okay, so we have a 9w squared plus a 30w
I'm on this and
plus 25.
Who do you have?
Instruction.
No, notes.
I got notes. I finished that.
So then you just.
Wait.
2 more problems, we're almost done.
Are we gonna do like a worksheet?
We don't do worksheets.
I
in here.
mean,
That's
no,
not
like,
true.
we just.
Next one!
Look at that sticker.
What worksheet did you
That
get?
sticker?
Was that even graded? It wasn't even graded.
It's participation points.
Oh, that's yeah, it's not graded. 'Cause I thought I failed.
See?
Did you check them?
Yep.
Did I do horribly?
You know,
I always check them like against your exit slips as you're going and see if I need to have you do more or if it was just small things.
Oh wait, do I have to do the exit slip for
3x to the third plus 5x.
Do I have to
We're
do-
gonna multiply that times 7x squared minus 8. Okay, so we're still doing the whole distributing thing. Okay, so 3x to the third times 7x squared gives us what?
21.
21 next to the fifth.
21x to the fifth. Then we're gonna go to the next one.
Negative 29 shit.
Negative 24.
Negative 24. X to the
Third.
third.
I know we flipped on.
Add an exponent on this. Let's
Mm.
put I don't know. Let's
One.
put a
3.
A 2.
4.
4.
Ooh.
16.
Close off by 10.
A 4. I don't know, my brain is working slow today. Okay, so now let's distribute here.
35x to the 6.
To the 6. Does that match anything we have?
No.
So where do we think we should write it?
In the front.
Above.
And before the
Why
front.
do you say in the front?
Because standard
Standard form
Something, I don't know.
says we need the largest exponent to the smallest exponent.
Yeah.
Now, if you wrote it later, that's fine. You just have to pick the right order when you put it down in its final answer. It's a positive 35x to the 6th.
Oh.
And then what's our last one?
40
Negative.
x to the
Negative 40x to the 4th. Where should I put that?
In between the 5
This
and
kind of
4.
needs to go in here.
Yeah.
So it's okay if we don't have any that match up. If there's nothing to combine, that's fine. But just like we were talking about with adding and subtracting, we still need to make sure that our final answer is in standard form.
Oh, see, I try to put it in order of like the exponents. I guess I did that wrong.
Whew.
That is a long answer.
That can get long, but can get pretty annoying.
That's 5 binomials.
Which is why we have to learn.
Okay, so this is why I teach it with distributing, right? Because it's really easy to just take that concept and apply it to anything else that we see. Whether it's binomials, trinomials, whether it's 100 terms. You can then look at a problem that's slightly different and still go, oh yeah, but I bet I probably know what I need to do. What do we probably need to do first up here?
I thought you said that foiling only applies to binomials.
Foiling only applies to binomials. If you only know first, outside, inside, last, that's not going to work here because there's no really first, outside, inside, last. But if you know to distribute,
Oh, okay.
what should we do first?
Distribute that
Multiply
x
the
over.
x.
So x times 5x squared is
15x squared.
No, wait.
Wait, what?
You're
10x.
5x to
What?
the third.
Wait.
you
Oh.
have a number in front of your x on your paper, don't you?
I'm working ahead as far.
You're on the negative third.
Yeah.
Okay, so then we'll go here. What does that give us?
Oh, she's coming up with.
Negative, wait, no.
Negative 7x squared.
Yep.
Sorry.
Because what exponent's on this?
Invisible ones.
Yep.
And then plus for
plus 4x.
X.
Now, Dylan, we're ready for your number.
Alright.
Negative 15x.
And where are we going to write the negative 15x squared?
Between, right below the 7x
Not
squared.
squared.
Yeah.
Oh, yeah.
Is it already assumed?
Yeah.
What's this one going to be?
Alright, negative 21x.
A negative and a negative makes a positive.
Yeah.
Oh.
I read it too fast. It's okay.
Last one.
Oh, plus 4. 12. Negative 12.
Yeah. There you go.
So again, by having that stacked look, you don't have to start searching for the like terms to combine. You can just go straight down. So our 5x third to the third comes down. Minus 22x squared plus 25x
Minus 12.
minus 12.